Okay, here's a topic that will be on the exam that was not covered in the study guide. So you will have a couple questions that will give you a linear inequality, and a couple questions will just be really simple and ask you whether, looking at the inequality, can you decide if the line should be dashed or solid. So just to review, if the inequality is less than or greater than, without this equal to portion, it's going to be a dashed line. So if the inequality looks like this or this, that means the actual line is not included in the solution, so we dash it just like we would put an open circle when we don't want to include something. It's going to be a solid line if the inequality looks like this or like this. Less than or equal to, or greater than or equal to. Okay, so on the exam, you're going to have something like this and have to pick which graph looks like it. So what you do is you imagine this being the equation y equals negative x plus 5, and you graph it. Well, this is in slope-intercept form. So since the y-intercept is positive 5, you go up to positive 5 on the y-axis. And since the slope is negative 1, that means from positive 5, we're going down 1 and over 1. And once I get a few of those points, I take a straight edge and I connect the points, but I keep in mind that since the symbol is greater than and it's not greater than or equal to, I'm going to connect these in a dashed pattern. And now since the original problem says y has to be greater than this line, greater than means above, so that means we're going to shade everything above the line. And that's the graph you would be looking for. Now you will also have some questions that look like this. It might say, is the point 2, 1 a solution? Okay, so to figure that out, you can look at the graph. 2, 1 would be right here. And since it doesn't fall in the shaded region, we would say it's not a solution. If you didn't have the graph, to figure out if 2, 1 is a solution, we're going to put 2 in place of x and 1 in place of y, and we're going to see if this turns out to be true. So it looks like this. If y is 1, and if x is 2, we need negative 2 plus 5. Negative 2 plus 5 is 3. So we get this solution. 1 is greater than 3. That is not true. That's false. So it's not a solution. Okay. All right, the next example, you should notice that the inequality is less than or equal to, so it's going to be a solid line. So we go to negative 10 on the y-axis. That's the y-intercept. And it has a slope of negative 1/2. So that means we go down 1 and over 2. Or if we want to work this way, we go up 1 and to the left 2. We connect those with a solid line. And it's saying y is less than or equal to, so that's everything below. Okay. The last example, it is not in slope-intercept form, so you have to use the 2-intercept method to graph this. So when x is 0, 3 times what gives you negative 12? So that's negative 4. So we plot the point 0, negative 4. And now when y is 0, 2 times what is negative 12? That would be negative 6. So we go out here to negative 6, 0. And I look at the inequality sign. Since it's just a greater than symbol, we're going to connect it with a dashed line. Now, because this inequality is not solved for y, it's not y is greater than a whole bunch of stuff, we can't just look at this symbol and decide above or below. So what we do is we're going to pick a test point. So I'm going to pick the point 0, 0 to test in the inequality. So when I put x is 0 and y is 0, 2 times 0 is 0 plus 3 times 0 is 0 is greater than negative 12. Is this a true statement? Is 0 greater than negative 12? Yes, that's true. So that means we're going to shade the portion of this graph so that 0, 0 falls in the solution region. Okay, so now I'd like you to trim this down and put this as your last entry for this semester in your interactive notebook, and the title will be Graphing Linear Inequalities.